Okay, welcome to our Chapter 3 review. Let's begin. Samantha was doing her math homework. She wrote 9 plus 9 plus 9 plus 9, which is another way to show what Samantha wrote. So we're looking at the expressions A, B, C, and D to see which is a good way to show what Samantha wrote. Michael. Great. So we have 4 9s here. So we're adding 9 4 times, which is the same as 4 times 9. Second one, Dakota is playing a math game with Madison. Dakota wrote 7 plus 7 plus 7 plus 7. So use the strategy from the last problem and apply it to this one, which is another way to show what Dakota wrote. Joanna. Great. So remember, anytime we're adding, no, I'm sorry, every time we're adding numbers, the same number over and over, repeated addition, we are actually multiplying. Mrs. Bennet sorted spools of thread into 4 containers. Each container held 5 spools. Mrs. Bennet skip counted to find the number of spools. How many spools of thread does Mrs. Bennet have in all? So if Mrs. Bennet skip counted, then we should do the same thing. Let's skip count together. Ready? Remember, there's 5 in each container, so we're counting 5, 10, 15, 20. So how many does Mrs. Bennet have in all? Isabella? 20 is correct. Nina bought 2 packages of fuzzy mice toys for her cat. Each package contained 8 fuzzy mice. Which sentence shows the number of fuzzy mice toys she bought in all? So remember, whenever we're writing a multiplication sentence, the first factor is the number of what? What's the first factor representing? The number of, or groups, right? Groups. The second factor, and remember, factors are numbers that we're multiplying together to get a product. Good, Mia B. First factor is the number of groups. The second factor is the number of what? Kyle.
Number of mice.
Okay, so number, in any problem, it would be the number of items in each group. And then the product is the number in all, the total. So using that formula, who can tell me what the correct number sentence would be for these 2 packages of 8 mice? Jojo.
2 times 8 equals 12.
Great. Next one. Martha bought 2 vases of flowers at the store. Each vase contains 6 flowers. How many flowers did Martha buy in all? So before you solve this one, I want you to tell me a multiplication sentence. Use that same strategy or the same formula from the last one. First factor is the number of groups. Second factor is the number of items in each group. And then the product is the total. So it's just asking for a product, but let's practice writing the sentence. Abby, what's the sentence?
2 and 6.
2 times 6. Great. So we had 2 groups, 6 flowers in each. How many, Abby? What's the total? The product? 12. Great. So we have 12 flowers in all for Martha. Next one. Carla used 3 shells in each of 4 necklaces. Write a multiplication sentence that shows the total number of shells Carla used. Now, before we do this one, I want to talk about some key words here. So this word, total, we've seen this for a long time in word problems. And what do we usually think of when we see the word total? What operation does that usually tell us? Juliana. When we're told to find the total, we usually do which operation? Addition, right. Which other keyword is in this word problem that tells us we are not adding, we are multiplying to find the answer? Christina. Well, yeah, multiplication sentence, but let's imagine that wasn't there. No, not number of shells. There's a special word that tells us to multiply. What is it, Jojo? Necklaces. What's the word? What's the key word? No. No. Who knows it? Mia B. Each. This word each tells us that there are equal groups. So there are 3 shells in each of the necklaces. 3 shells in the first necklace, 3 shells in the second necklace, 3 shells in the third necklace, and so on. So that means that we have equal groups of shells for necklaces. So who thinks that they can tell us how many, if we wanted to draw a model, how many large circles would we draw? Isabella, think about it. What are the groups? 4, right? Because the groups are representing the necklaces, number of necklaces. So 4 necklaces, 3 in each, right? These represent the shells. So now we have a picture to represent our multiplication sentence. Who can tell me what the sentence is? Remember, number of groups times number of items equals the product. Joanna. Great. Boys and girls, so we would, of course, label this 12 shells, right? Because we don't want to leave a naked number there. Boys and girls, if I wrote this as my answer, would I be correct? Mm, well, so we talked about the fact that the number of groups should be first. But does it make a difference in our answer? No, because of which property of multiplication? Which property of multiplication tells me the order of the factors doesn't change the product? Annabelle, the commutative property of multiplication, right. So I can change the order of my factors and it doesn't affect the product. Great, next one. Savannah placed 6 oranges in each of 5 boxes. She can use 5 times 6 to find the total number of oranges in all. Write an addition sentence that is equal to 5 times 6. Let's make an array for this one, just to help us. So there's one group of 6. There's another group of 6. How many groups of 6 do I have to make all together, Kyle? 5 groups of 6. Here's the third group. So here's my array. I have 5 rows with 6 X's in each row. So I think most of us are counting to find a product. Who can tell us the addition sentence that we could write for this? You all had practice with this making your array project. So who can tell me what the addition sentence is? Joanna. Okay, so let's just look at, we're going to add this row plus this row plus this row plus this row plus this row. So switch it around. So that's 5 sixes, right? We made 5 rows of 6. Now Joanna was going to switch it around and do this instead. Would I get the same answer? Hold on. If I did 6 fives or 5 sixes, would I get the same answer? Yes, I would, because it's the commutative property, right? So think about if I took this array, I'm going to just erase these lines that I drew, and I'm going to show you something cool. Just going to redraw some of those X's. Now, I'm going to demonstrate, whoops. I'm just going to demonstrate what Joanna said. I'm going to move this out of the way. So right now I'm showing this, 6 plus 6 plus 6, because I'm looking at each row. There are 5 rows of 6. To show this array that Joanna originally said, I'm going to make a group. And now I'm showing 5 plus 5 plus 5 plus 5 plus 5. So I'm getting the same answer. There are still the same number of objects there. I think it was oranges we were working with. So how many oranges does Savannah have? Whether she shows it this way, which matches this number sentence, or this way, which matches this number sentence, how many does she have? Jojo? 30 oranges. Excellent. Now, John Looney, would you, if you were counting these, which way would you count them? Would you count by 6s or by 5s? So it's easier to skip count by 5s than 6s. So it's easier to skip count 5 6 times than 6 5 times. Good job. And that's the commutative property again. Mrs. Perkins divided her class into 6 groups for a field trip. Each group had 4 students, so we have a nice model there. How many students were on the field trip? What are we going to do to find the answer to this one? Christina? We can multiply. What would be the multiplication sentence?
4.
Great. And then we can, if we're not sure what that fact is, we could skip count because we have a nice model here. What would we be skip counting by for this one? We have 6 groups of 4. What will we skip count by, Gianna? I think it's easier to skip count by 4, right? Let's do it. 4, 8, 12, 16, 20, 24. Great. So there are 24 students going on the field trip. Sarah was doing her math homework. She wrote 6 plus 6 plus 6, which is another way to show what Sarah wrote. Lucas.
3 times 6.
Right. Rachel drew an array to show the number of stamps on a page in her scrapbook. Which multiplication sentence shows the total number of stamps on a page of Rachel's scrapbook? So take a look at that array. See what we have there. Count the number of rows and the number in each row. Everybody should be able to find the answer. Michael, what is it?
3 times 4.
Okay, so now look at the choices. Michael says 3 times 4. So look at the choices. Great, Michael. So you use the commutative property, flip-flop the factors, and we have 4 times 3 equals 12. Great job. Next one. Luis has 3 boxes of cars. There are 3 cars in each box. How many cars does Luis have in all? Why did they give us a number line here? What do they want us to do with the number line, Richie?
Skip count.
Skip count by what?
By 3s.
By 3s. How many times do I have to skip count by 3?
3.
3 times. Excellent. So we're going to start on, we always start on 0, right? So here we go. 3, 6, 9. Great. So he has 9 cars. Now there will be questions on your math test that will give you that number line. That's a nice little treat. Number 13, Paula drew this array to show her artwork, how her artwork is displayed on the wall. Which multiplication sentence does this array show? Everybody count. Do a quick count. Look at the choices. I'll move my pen along the rows in case you can't count them from your seat. Mia P. Great. 7 times 3 equals 21. All right. Melissa says that when she multiplies any number by a factor, pay attention to this one because there's going to be one very similar on your test. When she multiplies a number by any number by a factor, the product is always 0. What is the factor? How do you know? So she can multiply 5 times the factor and the answer is 0. She could multiply 8 by the factor and the answer is 0. She could multiply 1 by the factor and the answer is 0. Any number she multiplies by this factor, this mystery factor, the product is always 0. What is this mystery factor? Michael, it's 0. How do you know?
Because each time you do say if it's like 6 times 0, then it's always going to be 0.
Great. What property of multiplication tells us that any time we multiply a number by 0, the product is 0? Christian? Yes. So if we had to write an explanation on our test, for example, that tells how we know that the mystery factor was 0, we could say, I know because the 0 property states or says that any number times 0 I should write the word times 0 is 0. Excellent. And that's it for our chapter 3 study guide. That's all. See you next time.